Okay, I did take some photographs. Okay. And see if I can align this the way the, yeah, it's just like this. There we go. Over here. And we're trying to see that capacitor in the back. Oh yeah, wow, did I ever make a mistake there, didn't I? How many of you caught that? No, Jim, don't do that! And you know why it happened? Because I cut two components at once. And, where's my tool here? And got confused right away about which one came from where. I'm glad I caught that though, really. Boy. I suspect some of you would have been telling me about it afterwards. Since sometimes I think you as a viewer are getting a better look at the work I'm doing than I am while I'm doing it. And what am I doing? I'm looking for this. This connection doesn't go anywhere near where I had it. It comes way over here. You know, does that look okay? It doesn't look okay to me. It does not look okay. It's probably okay like that. There we go. Now, push it back there. So this one's really just going to ground. This one here. I've installed it with really short leads. And we will do the same. Now, which one is that? That one is, it's going between two pins. It's going between pin number 7 and pin number 3. Pin number 7 and pin number 3. Right. We're going to look. Pin number 7, pin number 3. Pin number 7, pin number 3 on a 1H5. 1H5, pin number, what did I say? Pin number 7, pin number 3, I think is what I said. 7's a heater. What? Pin number 3 is the plate. What would be going on there? What would be going on is I got the pin numbers mixed up. Let's check that again. It's going between pin number 7 and pin number 3. 7 and 3. And 7 is taken to ground. 7. Oh, 7's taken to ground. It's just a ground point. Okay, so it's not really between 7. It's really on pin number 3. Okay. Pin number 3. No. Nah. I don't care that it's pin number 3. Well, I do care. What am I saying? Must be time for more coffee or something. That's the plate. That's the plate. That's the plate. And there's a 150 picofarad. Oh, wait a minute. There's another one right there, 0.01. No, this one goes to ground right off that pin. So it's got to be this 150. Yeah. So 150 picofarad. Here we go. 150 picofarad. Have I got something like that? And I think the short answer is, well, I'm going to have to hunt around a little bit. And what is it doing anyway? It's going to ground. It's going to ground off the plate. It's small compared to this one. So I think you're trying to ground away some high frequency stuff and let the low frequency stuff through, the audio stuff. I think. I don't really know for sure what that's doing there. But does it have to be 150, or it just has to be very, very tiny? Because it's just a just grounding signal. And I'm getting myself ready to put something in there that's a different size from what's here, because I don't think I have 150. 150 picofarads. I can't remember. 150. 150. I'm going to have to measure a couple of these. Well, I don't my meter, it must go down this low. So we'll take one of these. I think these are 50s or 100s. That allows you a way to check capacitor here. 0.1, I'm pretty sure it's a 0.1. I don't know. They get all kinds of readings off it. Crummy meter. Well, anybody's guesses. Didn't tell me a thing. I am not happy about that. Now, do I have another meter that'll read capacitance? You know what? I don't think I do. This one reads everything but. I don't think this guy will either. DC, AC, DC, micro. Yeah. So, what are we going to do about this? I'm sure I read these the other day. Figured out what they were, and now I can't remember. I'm kind of stuck here. I have no alternatives. There, that's good. That's a good solid reading. 0.7. 1. There we are. 1. Okay, so 1 what? This is 1 nanofarad. 1 nanofarad is 1,000 picofarad. 1,000 picofarad is pretty big compared to what we're looking for, because we're looking for 150. We're not looking for 1,000. We're looking for 150. So I want to have another tray of oddballs here. 150. 150. too big. So these are very, very tiny capacitors. It's way over 2. That's 10 nanofarads. 10,000 picofarads. Way off. I'm not getting there. But wait, not to give up quite yet. Real chunky ones here. This one says 25 picofarad on it. Let's see what it actually shows. .8. It's 800 picofarad. 0.01 M. 8. Well, let's go on for a while. I'll bore you with it while I hunt one down here. Okay, so after hunting and searching all over the place, the best I can do is a 100 picofarad capacitor instead of the 150 that's called for here. So I'll have to go with that. You know, should I put a? Maybe I should put 2 of these in parallel. Then I'd have a higher capacity there. I don't know what to do. You know, it's just like a neutralizing capacitor. Probably to take some high frequency ringing or oscillations out. Let's just put this guy in. Let's put 1 in. So we're going to go between here and here. This capacitor I just put in is right in the way here. No doubt about it, I've got to order a set of tiny capacitors. It seems like there's certain radios that have these tiny, tiny capacitors in them, and many others don't have anything anywhere near this tiny. So I don't really know why that is, but I guess it's a design thing. I'm working in the dark here. There we go. see one in the background there, eh? Right back in there. That's the next one we want to go for. I'm getting it. There we are. That appears to be right across the speaker terminals, doesn't it? That one is a 0.007 millifarad, microfarad, millifarad, right, 0.007. Oh, I don't have a 0.007, I got a 6 and an 8. 6 and an 8. What's this one doing? Oh, wait a minute. I'm out of 6s, so we're going to put an 8 in there. I'm going to put an 8. I don't know what that number is there. 0.008. Whoops, I saw it there on it. Thought I saw it. 0.008. Okay. Ooh, watch out, watch out. Got a fine wire right just over here is the coil. And some fine wires hanging out there just waiting to get hooked by something. But I did not oblige. I think one of the things that's surprising about a radio like this is it has those power-hungry vacuum tubes in it. Yet, in fact, this radio is not power-hungry. The vacuum tubes draw very little current. And since the radio is a high-voltage radio, all these vacuum tube radios are high-voltage radios, they tend to have lower currents, so I squared R works in your favor. The lower I, and the I is, it's proportional to the square of the current, so since keeping the current down, you're really knocking back wasted heat. When you get a transistor circuit, you say, oh, transistors don't have heaters. Well, transistors are in themselves heaters. They heat up a little bit. Big powerful ones, of course, output ones and that, they have to dissipate a lot of power, just like a tube would. Just the fact that they don't have a heater in them, going right on the terminal here. Because they don't have a heater in them doesn't mean they're perfectly efficient. All the componentry around the transistor has to carry the current that the transistor uses. So ultimately, yeah, transistors, I'm not going to try to tell you they aren't more efficient, but the difference is not so much. It's not so much. And this radio is a good example, and all these battery-driven radios are excellent examples of how tubes were made that were very, very efficient. Bad smelling smoke coming out of this radio every time I solder something. Since I'm right over top of it here, I'm getting a real good face full of smoke, which I certainly try not to inhale. But inevitably you're going to inhale some of it. Another one done. Let's just go a little bit over this one. And voila, the next one, right there.